Hello. Yes, we welcome you back to PSSB with me, Richard here. Yes, we are looking at this question. It says that consider the following: ethanoic acid and hydrochloric acid. Okay? And we say write the equilibrium equation representing the ionization of each. Okay? What do we do here? Okay, we have to know that ethanoic acid is CH3 COOH. Okay, and the ionization is aqueous. If it ionizes, it will give you ethanoate ion plus hydrogen ions. Okay, yeah, both aqueous. Alternatively, you can have water with it. So, yeah, let's look at the alternative. You might need it. Alternatively, you can say CH3 COOH plus water. Okay. Then this one being an acid according to Bronsted-Rowley. It donates a proton here. This one receiving a proton. It becomes hydronium ion. Okay. And this one losing a proton. It becomes ethanoate ion. So both equations are the same. Okay, that is for ethanoic acid. How about for hydrochloric acid? Okay, we can say it is HCl aqueous. Okay, ionizing to give you H plus aqueous plus Cl minus aqueous. Okay, the question is, why do you use a single arrow in one direction? You have to know that HCl is a strong acid which is completely ionized. So we don't have any HCl. So it goes in one direction. But I need to caution you that actually it is not completely ionized. There is some reverse reaction taking place, but at the moment, this is what we have to believe. Okay, suppose we involve water. Okay, it's the same reaction. What are you going to say? HCl plus water. Okay. Okay, now this is the acid donating a proton here according to Bronsted-Rowley. And on getting a proton, we have hydronium ion. Okay. On losing a proton, you have the chloride ion. Both are acceptable. Yeah. Then comes this question. It says, write the expression for the acid dissociation constant of each acid above. Is that okay? How do you go about that? Okay, you have to know that this expression, we derive it from the equilibrium. So if the equilibrium for ethanoic acid is CH3 COOH, on ionization we get CH3 COO plus H plus. So you have to know that this one is aqueous, the ethanoate ion is aqueous, and this one is aqueous. Okay. So if we intend to write the Ka expression, what do we do? Okay, we write it the same way we write the equilibrium constant. So what are we going to have? We are going to have the concentration of the products over the concentration of the reactants. So what are we going to have here? it's going to be concentration of CH3, COO minus. That's the ethanoate ion into hydrogen ion over CH3, COOH. Okay? That is the expression. But suppose we used the other expression which has water. What is it? Where we have CH3, COOH, which is the ethanoic acid reacting with water to give you have to remember that this one is the acid. It donates a proton here. This one, on receiving a proton, it becomes hydronium ion. Then this one, on losing a proton, it becomes the ethanoate ion. So suppose this is what we are having. Okay, how do you go about it? Okay, the Ka will be Ka, which is the concentration of the products, which is going to be that into the ethanoate, which is going to be that over CH3, COOH into water. But what do we know about water? We need to remember that water technically remains unchanged. So we leave it out. And when you leave it out, what do you get? What you get is going to be that which is the concentration of hydronium ion into concentration of ethanoate ion over concentration of ethanoic acid. Which is exactly the same as this. So both approaches give you the same Ka expression or the same acid dissociation constant. Yeah. Next we go to hydrochloric acid. Okay. We want the Ka or acid dissociation or acid ionization constant for hydrochloric acid. How do you go about it? Okay, we get it from the equilibrium. It is HCl aqueous. Okay. On ionization, we have H plus Cl minus. Okay, both aqueous, meaning it's dissolved in water. So from here, what else are we going to do? We're going to have the Ka. So Ka is equal to concentration of the products over concentration of the reactants. But you have to take note that here we have used one single arrow pointing in one direction, implying that hydrochloric acid is completely ionized. So what are we going to have here? We are going to have, okay, concentration of H plus into concentration of Cl minus over HCl. But I need to remind you that HCl completely dissociated, so we don't have it. So what are we going to have as our final expression? Our final expression is going to be Ka giving you hydrogen ion concentration into chloride ion concentration. As simple as that. Okay, but suppose you are using that equation which involves water. What are we going to have? We are going to have HCl plus water. Now HCl is the acid, so it donates a proton here. So on receiving a proton, what do we get? We get hydronium ions. On losing a proton, what do we have? We have chloride ions. Okay. Then we come to writing the Ka expression. How do we deal with this? Okay, this is what you have to know. That Ka is equal to concentration of the products of a reactants. So we are going to have concentration of our hydronium ions into chloride ions over HCl concentration into water. But you have to remember, what you have to remember? You have to remember that, first of all, water technically remains unchanged, and hydrochloric acid completely dissociated, so we don't have it here anywhere. So with that, what do we get? With that, we say that our Ka is going to be a concentration of hydronium ions into concentration of chloride ions, which is similar to the upper one. Yeah. Then we come to this question. It says, compare the acid dissociation constant of ethanoic acid to that of hydrochloric acid. Write higher, lower, or the same. Explain your answer. Okay, what are we comparing? We are comparing ethanoic acid to hydrochloric acid. So what is the answer? The answer is lower. Okay. What is the reason? Okay. The reason is that ethanoic acid is incompletely ionized. It's a weak acid, whereas hydrochloric acid is a strong acid which is completely ionized. So that means that the Ka, or acid dissociation constant for ethanoic acid, is lower because it's partially ionized compared to HCl, which is completely ionized. Yeah, that is that. Ethanoic acid is weak and completely ionized, while hydrochloric acid is strong and therefore completely ionized. Yeah, then comes this question. It says, compare the pH of ethanoic acid to that of hydrochloric acid. Write higher, lower, or equal. Okay. Yes, we are comparing ethanoic to hydrochloric acid in terms of pH. What's the answer? The answer is higher. Okay. Why? Okay, you have to know that ethanoic acid is partially ionized. It's a weak acid. So it releases less hydronium ions. Now you have to know that the less the hydronium ions, the bigger is the negative log of that number. So the answer is higher. Yeah, so that is it. Reason being that ethanoic acid is a weak acid, so partially ionized, compared to hydrochloric acid, which is a strong acid, so completely ionized. So you have to remember that the lower the hydronium ion concentration, the higher is the negative log of the hydronium ion concentration, and negative log of that number is the pH. Yeah, then comes this question. It says that compare the conductivity of HCl hydrochloric acid to that of ethanoic acid. Write higher, lower, or the same. Okay. We are comparing what? We are comparing HCl to ethanoic acid. Okay, what's the answer? The answer is higher. Okay. What's the reason for being higher? The reason is that hydrochloric acid is a strong acid which is completely ionized compared to ethanoic acid which is partially ionized. So when a hydrochloric acid is completely ionized, what happens? It releases a large amount of ions or creates a large concentration of ions. And we have to know that those ions are the one responsible for conductivity. So the higher the concentration of ions, the higher is the conductivity. Here, that is it. HCl, strong acid, completely ionized, leading to high concentration of ions, which lead to high conductivity. Meanwhile, ethanoic acid is a weak acid, which is partially ionized. Yeah, then comes this one. It says that compare the rate of reaction of HCl or hydrochloric acid to that of ethanoic acid. Write higher, lower, or the same. Okay? Yes, we are comparing what? HCl to that. The answer is higher. Okay? What's the reason for being higher? The reason is that HCl is a strong acid which is completely ionized, releasing large amount of ions, creating large concentration of ions. And you have to know that rate of reaction is proportional to concentration. The higher the rate of reaction, the higher the concentration, the higher is the rate of reaction. Yeah, that is it. So, HCl, strong acid, completely ionized, creating high concentration. And we know that one of the factors which affect rate of reaction is concentration. The higher the concentration, the higher is the rate of reaction. Meanwhile, ethanoic acid is partially ionized because it's a weak acid, creating less concentration, leading to lower rate of reaction. With that, I would like to say thank you. The channel is PSSB with me, Richard. So, we urge you to subscribe, to comment, to like, to share. We remind you that the channel specializes in physical sciences, grade 12, 11 and 10, and natural sciences, grade 8 and 9. When you are using the channel, we recommend that you use the playlist. Just go to playlist and select the material which belongs to your level. Grade 8 and 9, choose natural sciences grade 8 or natural sciences grade 9. For grade 11 and 10, look for physical sciences grade 11 or physical sciences grade 10. As for grade 12, every chapter is presented independently. Just look for the chapter of your choice, and there you are. You'll have all the material which you'll need. With that, I would like to say thank you. Stay blessed. See you next time. Bye-bye.